Hello everyone, I'm Albert and welcome to adding AI or ML to your automations with AI Center. What ML models does AI Center offer? Great question. AI Center offers more than 25 pre-built ML models in document processing, object detection, text classification, sentiment analysis, entity recognition, demand forecasting, anomaly detection, and many more. If you want to use your own ML models, AI Center operates exactly how it would with a pre-built model.
Hello everyone and welcome to the afternoon session of our .NET Day. Happy to welcome you here, and we are going to talk about machine learning with .NET, GraphQL with .NET, and gRPC with .NET. So looking forward to these three sessions that are upcoming. But before we start, if you use JavaScript on a daily basis, and I'm pretty sure you do, then the WeAreDevelopers JavaScript Congress is the right event for you. So if you haven't heard about it, or if you haven't checked it out so far, please, here is the link. You can check it out. We have awesome speaker lineup with the inventor of Angular and many other JavaScript experts. So check it out and grab your early bird tickets. As always, please feel free to engage with us in the chat and use the Q&A function to ask your questions to the speakers. After every session, we will have a short 10 to 15-minute Q&A session with the speakers, and they will be super happy to answer all of your questions. And while doing so, please also respect our code of conduct. So here's a short video. Okay, welcome back, and let's start with our first session. I'm super happy to announce our first speaker. He is the co-founder of ChilliCream. He is a Microsoft MVP, and last but not least, he is very engaged in the open source community and an expert for GraphQL. So please welcome Michael.
Hi, everyone.
Hello, Michael. How are you doing?
Great, and I hope everybody is fit for some GraphQL.
Yeah, looking forward to the session. But tell me, you are joining us from Zurich, right? So how's the weather there?
Yeah, so it's a bit rainy if I look outside of the window behind.
Okay, so that's the perfect basically situation to also do this talk, right?
Exactly.
Okay.
So,
do you want to give us a short preview of what can we expect from your session?
So this is an introductory talk about GraphQL. We will explore what GraphQL actually is, why it was invented, and how we can make use of it in the .NET ecosystem.
Okay, perfect. Then I would say the stage is yours. Have fun and see you later for the Q&A.
Thank you. So hi, everyone. Today we are going to talk about GraphQL. And I know a lot of times when I do this talk, there are always people that don't have a clue what GraphQL is, or maybe have a wrong idea what it could be. And this is often due to the name GraphQL. But we will explore today what GraphQL is and why it was invented, who invented it, and why you should even care about it. So GraphQL was invented back in 2012, actually, by the company called Facebook. Everybody knows them. And they had a problem back then with their mobile applications. And what the problem was, we will explore in a little demo. This is a shortened down talk version. So we'll dive directly into our first demo to explore what is the main benefit of GraphQL and why did Facebook actually invent it. And then we will reflect on that part a bit. Okay, let's just dive in. This is not GraphQL, this is actually a REST API. And this is the Star Wars REST API, which is or was back in the past frequently used to show well-established REST practices. So for REST, we don't have a specification, and you essentially can write or specify a REST API in many ways. And this project tried to show a couple of good practices. And why this is used? Because the GraphQL demos that are established around that, they often use this example to show how you can make this this API essentially with GraphQL and why it's so good to use GraphQL. So Star Wars API means we have all the data in here that is related to Star Wars. Like we have people that are the characters of the movies, we have planets, we have films, and what have you. What I want to do as a little task to warm us up is to collect all the characters that appeared together in movies with Luke Skywalker. So all the characters that appeared together with Luke Skywalker in Star Wars movies. So how could we do that? Essentially, if we look at the REST API, we would maybe look at the people endpoint. And as we might expect, the people endpoint in the REST API exposes multiple people or characters. So when we call this API here, we get like Luke Skywalker, like C-3PO, and all those Star Wars characters. So very, very simple. And we can see there's a lot of data, and then we have things like references here. We'll talk about them in a minute. We also have a link or a URL representing the actual object for Luke Skywalker. So we could dive in here and then get a single Luke Skywalker object. And yeah, again, we have all the character attributes here, like name, height, and so on. And we also have references to other objects. These are in this example represented by URIs. So I have a URI to specific films where Luke Skywalker appeared in. And I could follow them and then get the films object, maybe. And I can again see that as a specific object has attributes about the movie and also again references to other characters. So these are the characters that appeared in that specific movie. So if you think now about the algorithm that I set, that collects all the characters that play together with Luke Skywalker in movies, then it's quite easy to write that in REST, right? We could fetch Luke Skywalker, iterate over the films, fetch all the films, then iterate over the characters in the films object, and essentially get the data that we need. I've implemented that with JavaScript. It's the only JavaScript you will see today, but essentially we will do what I said, grab Luke Skywalker, iterate over the films, iterate over the characters in the films objects, and then essentially push our characters object here to an array, do a little bit of data massaging to get the data in shape, and then we are essentially done. Okay, why am I talking about this? Let's have a look at a little unscientific benchmark here. So if we execute this REST query, and I can do that, you can see, and maybe you already guessed that from the implementation, or when I walked you through the implementation here, it's not quite efficient because we have 124 requests. And that's quite a lot. and that's just a very simple problem I had here, with a very generalized REST API. But this actually was a problem that Facebook faced with their first mobile applications. So when they introduced their first mobile applications, they implemented them with what they learned in the web. So HTML, REST APIs, and so on. And when they then delivered those to the user, they got a lot of criticism because these applications were very slow. Think about you're on a bus and you're driving to work, you have a 3G connection, and then you open up this Facebook application and it suddenly starts fetching 500 requests because it has to fetch the user, then fetch the stories for the user, fetch the comments for each of the stories, fetch the likes that each user has got, and so on. So that essentially led to very bad performance and also did fetch a lot of data that you don't need, because we just wanted the names of the characters here, but we fetched all the data that we didn't need. And you can see here there are 900 bytes here, another 900 bytes, and so on. And we have 124 requests, so there are a lot of data that we fetched that we never even need to use. So how would we do that with GraphQL? So there is a GraphQL implementation for this demo done by the GraphQL Foundation, and it uses actually the REST endpoint in the backend. And with GraphQL, we essentially work also over HTTP. We don't have to. It's not GraphQL doesn't have to run over HTTP, but in most cases it will. And most of the times we have a tool to explore GraphQL, like this graphical tool here, which is a little tool to explore the API and do GraphQL queries. What I can see here in my document explorer already is we have a query root, and that is essentially my root query type that exposes all the things that I can do with my API. And with my API, I can fetch all films, which will get the films endpoint and stuff in the backend and fetch from there the data. Or I can also get a specific person. And we want to get a specific person to fetch the characters that appear together with Luke Skywalker. So how would we do that? In GraphQL, we start the query very simply with the keyword query. And then we use these squiggles, not squiggles, but braces for like a JSON structure. And then we can dive into our fields that we want to fetch. For instance, I can say, okay, I need a person. I need Luke Skywalker. And I already know from my REST API that this person has the ID 1. And then I maybe just need the name of Luke Skywalker. And I could fetch that. And I get then just the name of Luke Skywalker. Remember, it uses the REST API in the backend. Okay. So, but what I actually want to do is all the names of the characters that appear together with Luke Skywalker in movies. So I can drill in. So let's go into the films connection that we have, our graph. And then I get from the films, maybe the characters. Sorry. And from the characters, I just want to have the name. Awesome. So this is my GraphQL query. It's very simple. And I just fetch it and get the data in the same shape than my query. And I can just get the data that I asked for. And that's one of the key concepts, that I can fetch all the data that I need at a specific point in time. And I only get what I asked for. And you already saw that is much faster. It was 2.4 seconds with the REST approach, but now with GraphQL, it's in the milliseconds. although we're using the same REST API in the backend. But that's very simple why that is so. Because the REST API and the GraphQL API are very close together in the cloud. So the GraphQL API can fetch with unlimited bandwidth from the REST API. And that then just sends down to the user that might have a very bad connection, sends down just the data the user requested down that maybe very bad data connection. Okay, so let's just get back into my slide and sum that a bit up. So with GraphQL, we just have one endpoint. Since we are issuing the query, so we as a consumer are specifying what data we need and essentially telling that endpoint what we need from the server. So we just need one endpoint, which makes it very simple to use. We can fetch everything that we need, all the data that we need in a component at a specific point in time. We can get that in one request. So we don't have to have these multiple requests and create this data waterfalls with these consecutive requests that build upon one another. And this means we don't have the problem of over or under fetching. And overfetching is the problem I initially told you about, that you fetch too much data because the REST endpoint might just expose the response structure like this, and you have to take like it is there. So with GraphQL, you tell the server what you need. On the other hand, we also have no underfetching, and that's every time when we explore the REST API where we have these references, that actually leads to underfetching because we have to do another fetch that fetches the data we need. So we underfetch because we just get the ID, but actually we want the name from the next object. And GraphQL, you already saw that. We could look at the structure, and we will look at that in more detail, is built on a strong type system. And that's different to Swagger because it's really a type system that is enforced by the GraphQL server. So a GraphQL server will never give us more data than we asked for, and it will never violate the contract that we have with the GraphQL server. So we never get an integer for a string or a null for a non-null field. And that's different to Swagger, where we have this detached schema, for instance, that could be violated because it's outdated or some other reasons. And really, this makes GraphQL really predictable to use because we are in control. We can consume whatever we want, and we only get what we asked for. So that's very important. So, okay. And apart from this, GraphQL is real-time, also real-time. And that is an improvement over the simple REST get fetch. We can do just get fetch, and we will have to look at that. But we also can provide real-time data. But let's talk about that in a bit. Okay. At this point, at a conference, people would then maybe raise their hand to ask a question and tell me that you can also do that with REST. You can do sparse fields. You can also have very dynamic endpoints, and that is true. But think about it. Every time we want to introduce more dynamics into our REST API, we need to go to our backend developer and ask that the backend developer to implement that. And even if we have sparse fields, they are not really allowing us to drill into data. We are limited with the URL length that is allowed, and there are so many factors. And if we look into such a dynamic request, maybe from the Amazon Shop API, it's very complex to read. And even if we looked at something like OData, it is very complex to read. And also, it's not clear what the data types of these guys are here. Is it here just numbers, or what can I put in here? It's not clear from the demo data that I have here. Okay. So REST is a bit trial and error. We try to implement a feature on our client side, then we discover it doesn't work out. We have to get back to our backend developer. He or she implements it, and we have these endless cycles of updating our backend to get these specific or special requests in that we actually need to improve our application. So with GraphQL, we don't have that. So what is GraphQL? GraphQL actually, as intended, is a very thin layer over your business layer. And this very thin layer was built to interact more efficiently with your API layer. And also give you a better tool to expose this business layer in a much richer way. In GraphQL, we have interfaces. In GraphQL, we have union types and stuff like that. So we don't have to reduce our business model that might be very, very human understandable in our programming language of choice, like C# or something like that. But often when we put it then to rest, it's reduced and oversimplified, and thus we have to make compromises. And with GraphQL, you get a much richer type system on top to express your business layer. But GraphQL is also a great gateway technology. That's why it took off so much. So often, if you go to JavaScript people that already do GraphQL for quite a while, then you see that they actually started with a very thin layer of GraphQL over their old infrastructure. That's why I said that the GraphQL, the Star Wars GraphQL API actually was a thin layer over your REST endpoint, or over the REST endpoint that I showed you earlier. Because it's very simple to just craft up the schema and then put REST underneath of GraphQL, and then already you have a very new way to interact with your old API, and you can slowly renovate beneath GraphQL to get to GraphQL native. Okay, at this point, backend developers might get a bit upset because GraphQL gives you the way to arbitrarily ask for data. It's actually the reverse for client-side people. Client-side people get these big eyes and say, that's exactly what I want. I specify what data I need, and you just give it to me. But for a backend person, this is the reverse, because they have the feeling of losing the control over their backend. And this year was a discussion with Airbnb devs when they introduced GraphQL. But it's actually a wrong understanding of GraphQL by backend engineers. GraphQL actually was invented by backend engineers at Facebook. So two of the inventors of Facebook actually were backend engineers. And that's why I made a point on the type system. GraphQL really gives you a much richer way to express your business layer, and by this also to mold the API in a way that people access your API in a way that you defined it. So you can essentially express the API in a much stricter way, and have all those type constructs that help you with that. And on top of that, you even can define things like cost directives that maybe control how much query cost a user can consume when doing a query. So GraphQL actually gives you all those tools to control your API much more. And I think that becomes more clear when we head into our first C# demo. And let's just quickly fly over these. So in GraphQL, we have three fundamental operations. We have the read operation, which we call query in GraphQL. That's what we did when we queried the Star Wars data. And it's essentially the get in REST. And then we have the write operation, which we call a mutation. And it's a put, post, patch, delete in REST. Last but not least, we have events, and that we call in GraphQL subscriptions. And that is essentially what I called real-time data. If we have enough time, we will also do a demo on that. Okay. Also, let's get quick to that. What is GraphQL not? Because I thought most people or many people in the beginning misunderstand GraphQL, and that is sometimes due to the name. And the first point on this list is GraphQL is not a graph database query language. Although the name is GraphQL, it has nothing to do with graph databases or any specific data source. You can put GraphQL over your application layer, you can put it over your database, but you can also put it over your old infrastructure like your old REST services. It also has nothing to do with OData. Sometimes people, especially in the .NET community, ask, why not use OData? It's established. Why should we even bother with GraphQL? Because GraphQL does so much more than OData and has a different mindset. So OData essentially comes from the database mindset. If you look at the old OData versions, OData 1, which we still consumed over the AtomPub protocol, it was more an abstraction of our database. It has developed in a different direction, but this is the initial mindset. If we look at Facebook's GraphQL, it was developed with an API mindset. So it's a query language for your API. That's the slogan. And you will see what I mean as we go through our demos. So GraphQL is also not a good solution for binary streams. So you don't have to do everything with GraphQL. GraphQL is great with data, with structured data, with data that has relations. That's where GraphQL is very good, but not with binary streams. While Netflix uses GraphQL in the backend, so every time you go on the Netflix page, you're essentially using GraphQL implicitly because their website is using that. But the streams that they do are not done through GraphQL. And GraphQL is not limited to HTTP. For instance, the real-time protocol of GraphQL subscriptions are running over WebSockets or other means of real-time connections. And also, queries could be run over TCP or something else. And GraphQL is not limited to the JavaScript world. In fact, the first implementation of a GraphQL client was for mobile applications with Java and Swift for Android and iOS. And the first GraphQL backend was actually a PHP server. Just as it was open sourced, it became so popular in JavaScript. Okay, that was my monologue on the what is GraphQL and why was it created. Let's dive into some code. Because we are .NET developers, let's explore some code. Okay, let's build a very simple GraphQL server. What I have here is essentially an ASP.NET Core 5.0 server. It has nothing in there. Essentially, if we go in the startup CS, you can see there is nothing in our configure section here, no service. We just have one endpoint mapped, and this endpoint just writes hello to the output stream. So I said GraphQL is actually about APIs, is a query language for your API. So let's create an API or a little entity. So let's start with a book entity here. And this book entity just has a property title and author. And we want to query that or expose that. So next, we need something to query this, expose that. In GraphQL, we have these root types. And each of the operations that I introduced, like query, mutation, and subscription, are represented by a root type that essentially gives us the entry points into our data graph. So let's create a query class and then think about how do we write a query class. It's essentially very simple. It's just a .NET class that exposes a method or property exposing the data that we want to expose. In this instance, our getBook method will create a new book object with some data, C# in depth here from Staib. Okay, so we have our query type, we have our data structure. How do we make it a GraphQL server? We just make sure it's compiled. So in order to host a GraphQL server is transport agnostic, as I said. So we just add it as a service. We can say add GraphQL server. Add that. And then we can say add query type. And tell our GraphQL server this class represents our query type. Okay, we're essentially done now. GraphQL server is there. It's a valid GraphQL server. We just need to expose it through an endpoint here. So instead of map get, we do a map GraphQL. And with that, we are done. Our GraphQL server is fully functional. Let's just fire it up, let it run, and see how we can query it. Okay. Oh, no. Okay. Coming up. Let's take that. 1 second. Okay. And that was not so good because. Okay, sorry for that. Let's just refresh that. I should have opened it as an incognito mode, but okay. So this is Banana Cake Pop. It's also part of our open source project. So Hot Chocolate is the server. Banana Cake Pop is our GraphQL IDE. It's much nicer than the GraphQL IDE you saw before. So just by doing map GraphQL here, we automatically have this GraphQL IDE hosted on the GraphQL endpoint as well. And we can explore our schema reference here. So I can dive into our schema reference, and I see I have exposed the query type here, and the query type has a field book, and that exposes the book type, which exposes author and title here. I can also query that very quickly. Let's do that. And let's just get the title of the book. Boom, I have the data. Very simple. But striking is here how simple we did it in C#. It essentially was just any C# class, and we knew how to expose this as the GraphQL server. There are also different ways to expose GraphQL. This is called what we've done here with Hot Chocolate is called annotation-based. There's also a Fluent API, and we also have the schema-first approach. But let's not go in complexities. Let's head to our next demo. And let me just undock that. Okay, this is how simple you can create a GraphQL server. But there's a lot more to this than that. So how would I actually query proper data from a database? And most people in the .NET ecosystem, they use Entity Framework, or maybe something else, but this demo I just use Entity Framework. Actually, in the projects I'm working on, we are mostly using MongoDB, but it doesn't matter. So Hot Chocolate GraphQL server will support anything you throw at it. Okay, so in this example, we added some more. We have the Hot Chocolate ASP.NET Core server package, but we also added an entity framework package so that Hot Chocolate actually understands the specific of entity framework. We made the API a bit more complex. So we have an author, we have a book, and we have a book context here. So essentially what we do in Entity Framework, create a DB context, have some entities around it, and then we can query our data. So how do we change our GraphQL server that I still have here essentially set up as we left it in the first demo? How do we advance that to be able to query data from the database through Entity Framework? So that is quite simple. Let's start with the configuration part. So we essentially go to our configure services section in the startup CS. And then we essentially add the DB context to our dependency injection. So I added here DB context, our book context, connection string to query our database that we have here as a file. And with that, the DB context is now available to me as a service. So now I can go to the query class, and let's kick out this resolver. These methods on the GraphQL classes we call resolvers because they are resolving data for our GraphQL server. Okay, in order to put our new books method in here, I just get that from my templates, and essentially I'm getting the books here, and I'm injecting a service into my resolver method. Resolvers in GraphQL are atomic, so they are self-sufficient. So everything I need to execute that resolver will be injected into that resolver. So I get my book context here, and then in this case, I'm just returning my books as a queryable. And with that, my data should already be exposed. Let's just run that to check if that is so. Let's run. There we go. 7 more minutes, and then okay. No. That is a bit pity. Okay, there is my GraphQL IDE again, and I just refresh it now, and I can already see that I get now the squiggles here. It's wrong. This doesn't fit our schema anymore, because actually we are exposing multiple books now, and we can get the title from that. And I'm just executing that, and I get the list of books here from my database. So that's how easy you can expose data with GraphQL. You just plug it in, you just return it, and we will fetch the data. You can also see here the SQL. It's not efficient at the moment. So if we want to make it efficient, we actually have to put some hooks in that come with the Entity Framework package. So let's assume we want to query our data properly, like we want to specify where clauses or something like this. Then we need something like filtering. So we can just pop into our schema that we want filtering support for our schema. We maybe want add sorting support, and last but not least, we might want to add projection support. So all this is now in, but we have to apply it in our resolver. So not every resolver will now have filtering support because it might have dangerous implications. So what we want to do is put this in where we want them. So let's put some in. So maybe we want paging, so that we don't get all the data at once. And we want projections, and projections essentially will rewrite the SQL to match the GraphQL. We will see what it does. Okay, next thing is we want to add filtering and use sorting. And what we see there is actually now a a middleware pipeline that is applied onto that queryable. Let's just run that again. Okay, it's coming back up. So I can refresh, and again, we get an error here because the data structure has changed. Let's have a quick look at the schema reference, and we can see now we have a books connection, which is a type that allows us to page. So we essentially have nodes that are the books, and now we have a page info where we are in the stream. And additionally, let's just get back to the query type. Additionally, we have all those fields, like first these paging fields, and we also have this where clause structure. Let's try that out. So maybe I want all the books that have a title that contains C#. Sounds good. We want the nodes and the title. Let's reformat that. Let's run that. Okay, there's all the books that have C# in. And what you can now see is, and that's what I meant, we are rewriting now the SQL to match what we actually want. When we look at the first SQL, you see it fetched essentially everything from that entity. But now we are knowing what fields we use in GraphQL. We just fetch what we request in GraphQL from the SQL backend. And this is done by essentially rewriting expressions and applying them on Entity Framework. We can do that as well with MongoDB and other data sources. If you want to do that, is up to you. There are different ways to put GraphQL essentially over everything. So the most common way you can do it with clean architecture, putting it on your business layer. You can put it directly on your SQL layer. So there are multiple ways to essentially upgrade your backend to GraphQL. Okay, I think for subscriptions we will have no time left, because otherwise you will have no time for questions. Here again, this is essentially the pipeline that we apply to our queryable to rewrite the SQL. And yeah, we are not making it real time, but you have survived the very shortened down version of this talk. Never tried before to do it in under 50 minutes. So conclusion, with GraphQL, you can iterate faster. You saw how easy I could build up the GraphQL server just with pure C#. And I essentially expose my business model like I wanted, and then the user, the consumer, can pick from that business model the data that he or she needs. And that really accelerates iteration time, because the front-end developer is not anymore limited by what is available on the backend in specific requests, because the backend developers expose all the data, or maybe just start with the schema and put some mocks behind this, and the front-end developer already can then build their requests for their components and start iterating. You are fetching data more efficiently, and it also takes away the complexity of data fetching. Because if you look at these GraphQL queries, swap over one more time, then it's essentially you're sending in an empty JSON graph. It's not like that, but it's a good picture to start with. You're sending in an empty JSON graph, and you get a filled up JSON graph from your backend. Again, it's not like that, but it's a good picture to start thinking about GraphQL. Okay, with that, I'm ready for questions, if you have some. Otherwise, you can also head over to a bookshop. This is a good book to get started with GraphQL. It's written by Marc-André. He's a senior developer at GitHub, and one of the first persons to really implement GraphQL at scale. or head over to our webpage, and then you can get into touch with us through our Slack channel, and we have a lot of support, community support on our Slack channel. Are there questions? I cannot listen to you. You are muted.
Should work now?
Yeah, I can.
Perfect. So thanks for the presentation. Very interesting, a very good overview and a very, very good presentation. Thank you so much for sharing all the insights. So first of all, how many people are contributing to the project?
It's over 100.
Okay.
I know it's yeah, it's over 100, but we have essentially 6 core contributors that
you are one of them?
every day. Yeah, I'm the one that came up with it.
Absolutely. So it's also like as always with open source technologies, just ask everyone if you like the project and so on, then just support it, not just use it, but also contribute to it. It's a very cool thing. And with that, I would say let's jump into the questions. So let me see what we have there. First general question, yes, you will be able to watch the recording also afterwards. So no worries if you came in late. You can watch everything on demand. And then Leo has a question. How would you implement versioning on the API?
That's a good thing. I would have mentioned that in the longer version of my talk. You don't. In GraphQL, you don't have versioning. You're more aligned in the way that you build APIs in .NET. In .NET, you don't version your objects. You obsolete things that you don't need anymore. And the same way you do it with GraphQL, you essentially apply an obsolete tag, track the usage of the field, and when there's no more usage, you could take it out or you leave it there forever as an obsolete field.
Okay, so Leo, I hope that answers your question. If you have another question, just please use the chat. Then Oli95 is asking, is MongoDB the only supported NoSQL database?
No, we are actually supporting Neo4j, for instance, which is a graph database. You can essentially put also something in that we don't support out of the box. It's a very abstract system, our query system, and you essentially everything that supports a queryable is supported, and also other things like Mongo. For Mongo, we re-implemented the driver to have to communicate over Bison objects to have a much more efficient communication with Mongo. So you can do more with our Mongo implementation than you can do with their queryable solution or their Mongo driver.
Okay. Then MRTN. So I assume it's Martin, but let's see. He's asking, how do you handle write management?
Write management. You mean if I'm allowed to write or not?
Write like access rights.
Yeah. Okay, I understand. So we have an authorization system. You can essentially, we are using the authorization logic from ASP.NET Core, so you can define authorization policies and you can apply them on objects or fields, and then we essentially make sure that the user that is logged in has matches the policy. Otherwise, you get an error for this field.
Okay, good. Then let me see the next question. JM has a very generic question. I'm not sure like if it fits, but how smart is the search?
How smart is search?
Yeah, I think I would say like as smart as the queries.
Yeah, exactly. So what I showed you there is, and as I said, if you do clean architecture, you won't have you might not expose as many query constructs that you would than you would with if you put it on a database. But I put it on a database there, and that means you essentially can do everything that you can do in SQL in terms of the where clause.
I think he clarified the question a bit. So he's writing, you did some contains C#. What if I misspell C# with a big S, for example, instead of C# with a small s?
As I said, it's rewritten into it's a direct rewrite into expression trees on top of Entity Framework. So it's as smart as Entity Framework is. So it's not smart at all. It's not a search engine. You could you could take something like Elastic, and then expose a field that uses Elastic, and then you would have the capability of an Elastic search, which then is more smart in terms of what it can query.
Okay. Victor has a very interesting question. Is ChilliCream GraphQL supporting stitching multiple existing REST APIs?
Yes, we have a stitching layer. So we have a GraphQL gateway. There are also talks, I think on channel 9, you can find a talk on schema stitching by me and Jeremy. And there we show how a schema stitching essentially works.
Okay, then Antonis, the next question. So questions are coming in really. Can we edit the data before we expose it like in REST APIs?
Yes, you can do that. So essentially in the resolver that I showed, in the get query resolver, it was very simple because I had to get that into, I think you guys said 35 minutes would be ideal. So I had to trim it. But yes, you can do that. In the resolvers, you can do whatever you want with the data and then expose it. So if you do, for instance, clean architecture, then you might also have like mapping layers. You have your data layer, then you have your domain layer, and you have all those things that are mapped, and you can do that. That we translate it right back to the database through all these mapping logic. But yes, you can manipulate.
Okay, perfect. And Kiko is asking, can you imagine or can you tell us use cases where to combine REST and GraphQL?
So why you would use both, or?
Yeah, that's how I understand the question.
There are, so we are actually also developing a service at the moment for the next version that can take GraphQL and translate it back automatically to REST. And that is sometimes useful because you have a legacy tool, like maybe for the specific use case you have Power BI, you want to expose the data that you have in your GraphQL, then you write a GraphQL query and that translates into REST to work with the Power BI adapters, something like that. And it's not exclusive. So like Facebook, for instance, if you go to the graph.facebook.com, many think that's GraphQL, but it's actually a REST API. So they're exposing REST, only REST to their customers and use GraphQL internally for their website.
Why would they do so?
Because it can be more controlled. And maybe you want to very strict control what users can do, then you're just exposing certain requests. But for your own developers, you want all the flexibility and all the performance benefits of GraphQL. So you let them use GraphQL. It depends a bit on the philosophy. Like GitHub, for instance, they are exposing the GraphQL API. So all the users have all the benefits of GraphQL. But they are also as well exposing REST. So it doesn't have to be one or the other. It could be both because you want to give more flexibility.
Okay, so I would say it depends on the use case.
Yes, it's with everything. Maybe you also expose gRPC, and Irina will tell you all about gRPC later. But you could also have all three of them for specific use cases. Or maybe you use gRPC internally, then GraphQL on the top. So there's a lot of combinations you can do.
Okay, so I see we are already a bit over time, but the audience, feels very engaged. So, Michael, you showed us a book that is good to start with. We saw your Twitter handle. It's at Michael_Staib, so your first name and last name, so people if they have other questions and so on. Perfect. Let's put it on screen again. And what are some other resources? As you said, like you had to shorten the presentation a bit down.
You will find versions of this talk like at NDC or on Channel 9. There's a series with me and Jeremy and Cecil from Microsoft talking through GraphQL concepts. There will be soon another of those talks with the Entity Framework team. So there are a lot of resources if you Google for us. And we are very proud of our Slack channel because we have, I think, over almost 3,000 users on our Slack channel where we provide community support. So it's a very vibrant community that we have. And
that's amazing.
Can head over there by if you go to slack.chillicream.com, then you can get into our Slack channel. It's open.
Well, that's amazing. And Michael, I want to say thank you again for joining us today. It was super interesting to talk with you and to see also your presentation. I hope to see you soon again at another event, maybe also in person. Would be very happy. I hope also that in Zurich the weather becomes better, so you can have a nice walk in the evening outside or something. With that said, thanks again, and see you next time.
Goodbye.
Bye. Okay, so thanks for being so engaged in the chat and asking your questions. I hope you could take some benefits out of the talk, and I'm pretty sure Michael will also be there for you if you just ping him on Twitter or if you have some questions or want to get started with GraphQL, ChilliCream, hot chocolate, and so on. I just hear from backstage that our next session is cancelled. That means that we will have a short break of around 1 hour and go into our next session at exactly 4 p.m. machine learning in .NET. So stay tuned, take the time to have a short walk or to do some work or to eat something or have a coffee or whatever you want, and see you again in 1 hour.
Hello everyone, I'm Albert and welcome to adding AI or ML to your automations with AI Center. What ML models does AI Center offer? Great question. AI Center offers more than 25 pre-built ML models in document processing, object detection, text classification, sentiment analysis, entity recognition, demand forecasting, anomaly detection, and many more. If you want to use your own ML models, AI Center operates exactly how it would with a pre-built model.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello everyone, I'm Albert and welcome to adding AI or ML to your automations with AI Center. What ML models does AI Center offer? Great question. AI Center offers more than 25 pre-built ML models in document processing, object detection, text classification, sentiment analysis, entity recognition, demand forecasting, anomaly detection, and many more. If you want to use your own ML models, AI Center operates exactly how it would with a pre-built model. Hello everyone, I'm Albert and welcome to adding AI or ML to your automations with AI Center. What ML models does AI Center offer? Great question. AI Center offers more than 25 pre-built ML models in document processing, object detection, text classification, sentiment analysis, entity recognition, demand forecasting, anomaly detection, and many more. If you want to use your own ML models, AI Center operates exactly how it would with a pre-built model.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello everyone, I'm Albert and welcome to adding AI or ML to your automations with AI Center. What ML models does AI Center offer? Great question. AI Center offers more than 25 pre-built ML models in document processing, object detection, text classification, sentiment analysis, entity recognition, demand forecasting, anomaly detection, and many more. If you want to use your own ML models, AI Center operates exactly how it would with a pre-built model.
Welcome back, everyone. Thanks for staying with us. And I'm super happy to announce our last session for today and our last speaker. He is the head of software development at Forward Pro. He's a Microsoft MVP and he's the co-founder of CloudGen Verona, which is a community for Azure and .NET. He loves everything AI related and machine learning, and this is why I think that we will learn something from him today. Please welcome Marco.
Hi, everyone.
Hi, how are you doing?
Very good, thanks. And you?
Good, good. The weather could be better, but it's the perfect time to be in this virtual event. So, Marco, tell me a bit about your session. What can we expect?
Well, today we will see the one of my the framework that I prefer, that is ML.NET, is a framework, a Microsoft framework that permit us developer to insert ML inside our project. And we see a little bit overview of some concept, and after we will see some code, and we try to make object detection using custom vision. So we make a small sample in where we can use ML.NET and also the cognitive services of the Microsoft Cognitive Services.
Okay, very interesting. So, Marco, we will see each other again after your session with the Q&A. Okay. Have fun. You can share your screen and start your presentation. See you later.
Okay. Hello, everyone. And today we will talk about ML.NET. And my name is Marco Zamana. I'm from Verona. I'm Microsoft MVP for the EA category. And you see there my contacts. If you want, you can write me on Twitter. You can find my rep on GitHub, and you can contact me also on LinkedIn. Well, we start to talk with you about this framework. We are talking about a cross-platform framework of an open source machine learning framework, and permit us. When I say the word us, I mean all developers, all .NET developers, permit us to use ML inside our project. As you can see, we have a framework that is extensible, that is open source, and also developer focused. And I think that there are a lot of developers like me that make the beautiful solution, the beautiful software, and when they finished their work, start to think, but I think that is beautiful, that will be beautiful, insert in this application some aspect of intelligence, of artificial intelligence. And in fact, ML.NET help us to do that. Let's see why, how. ML.NET has one particular thing. The net developer know what are NuGet packages, and ML.NET is NuGet packages. In fact, are a framework that we can insert everywhere and everywhere. We can use it inside a desktop application. We can use it inside a console application. We can use it inside a web app. We can use it inside a web app in Blazor. We can use inside a microservices application. We can use inside everywhere. And one step very important is the workflow about how we can use it. Now, let's see. There are three types, three methods that we can that help us to use ML.NET. The first is the API use. The API use is the most useful. For example, is what we'll do today. We can use code. So we open our IDE with Visual Studio, and we try to coding in C# or F#. The next step is the CLI. We can use MLNet CLI. In fact, we can auto-training. We can use the training model inside our CLI. It's very beautiful. It's very useful, and we can help us to training a model in a simple command. Very useful. Another possibility is the UI. Is the using of a model builder inside Visual Studio that can help us to create a sample tasks directly inside Visual Studio, and we have the possibility to use this model everywhere. And after we'll see. One aspect of this slide is this. Inside the framework, there are a lot of tasks that are very important for the use of our experiment. In fact, we have a data view, we have a trainer, we have a transform, we have the step of AutoML, and we have a lot of extension like a TensorFlow extension and an ONNX extension. One step important is the iData view. iData view is one of the most important concept inside the ML.NET world. And after we'll see when we coding after. Obviously, the supported framework is .NET Core, .NET Framework, and now also ARM. And the supported TOS are all the three OS that we know. The components are similar to components of other framework like Python framework. We have a API for transformation. We have API for the training. We have API for the explainability, for data loaders, for iData view, and also we have extension that permit us to use TensorFlow model or ONNX model inside our application. And this is very useful and very interesting for us. Use it use it for integrate our application also with model trained with other programs. The concept is that ML.NET is a set of API that permit us to build and train ML model, but also permit us also to run any model. The step important is the definition of the workflow of the code. In this slide, you see that there are two steps. The first step is the build of the model. The build of the model is the step in where our model is built by a dataset. So try to image this scenario. There is a data set. There is an application inside our company that collect a lot of data, and now we have to pick up this data and use it inside our model. So we have to collect this data, to load, and to create a pipeline that permit us to train our model. When we train our model, we start a first iteration that is not enough. We have to continue to improve our model for increase the accuracy of this. Is these the steps that are very important. We start to hide data view. We start to append our pipeline, and we start to train, and we start to improve. And is a workflow, a continuous workflow. It's clear that after this workflow, there is a one step in where our model is safe everywhere, anywhere. And this is this type. The second step is the use of this model. After we save it, inside anywhere, we have to pick up and we have to create a prediction engine using the API predict. It's called make a prediction by calling. Okay, so we load and we use this API. Two steps. It's obvious that I talk about the concept. We are talking about a practice like one of the one basketball player that I like is one of our scenario. We start to see one thing. The first is the MLNet CLI. I tell you before that there is this possibility. We can use ML.NET also in CLI. So we can open our PowerShell, we can open our terminal, and we can try to make a simple classification, a simple regression, a simple multi-classification. Inside there, simply write some parameters. So MLNet classification, the parameters dataset, where is the label, has either, and train time. This is very, very cool feature because you can create a simple model inline without any problem. Unfortunately, my personal computer is a notebook that is a little bit old, so I cannot make a direct and also run this. But we will see after in code something better. I want to steal another minute to talk about the process, because it is a vision of the meaning of the word inside the MLOps. We know that when we create experiment of machine learning, usually we use these three steps. The first step is prepare our data. The second step is build and train, and the third step is run. I show you with the API of ML.NET in the slide before. These three steps work each other between prepare your data and build and train, we pass dataset. Between build and train and run, we'll pass ML model. And after, we have a run of the model. These three steps are two different kind of job in reality. The first is the creation of the model, in where we have some tools that we can use to prepare our data set, to build and train our model, and obviously is not the place of the developer usually, is the place of data scientist. After there is a model consumption, there is a place in where there are our model, and the developer prepare something that the end user can use. So our model are included inside our application. Another aspect is the process to build around our model. With the task that ML.NET is a NuGet packages, we can insert it in small pieces of code or small application for making what we need. For example, we can create a simple application for build and train a model direct inside a console application, for example, or we can make some evaluation using the NuGet packages inside another application. Why I tell you this? Because at the end we have also a small packages for random prediction, and the word of ML.NET is very useful for this reason. If you have, for example, a web application where we want to insert something that permit the object recognition of a particular type of shoes, we can do. Simply add some NuGet packages inside the application and use the API of the framework. This is very useful. So in the real world, usually there are developers that collaborate each other for create an application. When we create an application, usually we make all the process of delivery. So we have a continuous integration, continuous delivery process inside our DevOps or GitHub action is the same. And we have the release of the application and the monitoring the application. This aspect is very important because the questions is that, but when will we insert inside this workflow the ML context? What happened? Is not possible that the workflow remain the same. We try to evolve it in this world. This world is the world in where we have the developer that collaborate each other and build an application in where training the model and make a process where the model continues to improve. We have a retrain model after this step. These steps are very, very important because the train model is the focal point in where after we have to validate. In every process of MLNet, in every process of machine learning, there is evaluation of our model, and use the .NET framework can help us about that. Deploy the model and monitoring the application is the fundamental step for pick up the data for the retraining. Let me say you that there isn't a model that is created one time and leave it alone. It's not possible. The model must be improved everywhere, every time. And the data are very important because we have to understand the data that we pick up, and we have to understand that how we have to manipulate this data for retraining our model. This is very important feature. So in this case, the step very important is the automatic deployment after the evaluation. So we insert this concept inside a pipeline that can help us to do that. Okay. Okay. Now we leave these the things, and now we will see some aspect of code. Okay. Okay. So what is the scenario? The scenario is a sample in where we can use ML.NET to make a prediction about a sample binary classification. So I create a new project. This project we can call sample WeAreDeveloper. On. Is the same. Netcore 3.105 is the same. And now let's see what happened. Now we use a model builder. Obviously, we have a simple application. And now inside the solution, we go to add new. No, sorry, not the new project. Inside the project, we go to add some machine learning model. We have a beautiful, Visual Studio asks us what is the name of the model. We make WeAreDeveloper at. Okay, let's see. We have a beautiful scenarios in where we have to decide what to use. We have a data classification, a value prediction, a image classification, recommendation, object detection, clustering, forecasting, anomaly detection. We have a lot of scenario where, in this case, sample we use a data classification. Select the training environment. This is a very interesting step because in this step we can also, for other scenario, not for this, we can also define a environment inside Azure. I want to see. Wait. Okay. As you can see, we can use our subscription in Azure for define an environment in where we can use Azure Machine Learning for instantiate a computer machine that can help us to train our model. In this test that we do, we use a sample binary classification, so we can use our local CPU. If we have inside our machine a GPU, Visual Studio help us and permit us to select GPU directly in this window. We make next step, and we can go to search a file. This file is a sample sentiment analysis, very, very simple. I have labeled. Okay. It's a very, very simple. And we make open. Give the time to preview. Okay. We have the tool that help us in where we have the phrase, the sentence, and we have the sentiment, positive or not positive. We need to select the label. What is the label? The label is the column that defines if the sentiment of the text column is positive or negative. We are training a model that understands from the sentence if is positive or negative. So our data set is is very simple, and we have two possibilities. Sorry. We define what is the label. The label is sentiment, and then we go to the next step. In this step, we are going to decide what is the time to training. The time to training is like to select the epoch inside a training model. In sense that there is the number of iteration that the model builder do for select the best algorithm to training this model. Now, here we use 10 seconds. So it's very simple. We have a countdown here. And I think that is because my give it okay. Need some time. Okay. As you can see, we have the training results in where we have the best accuracy of this model. It's obvious that we have training the model about 8 seconds. Is very for find the best accuracy, the system need more time. And at the same level, we cannot start a train about 3 days for a simple classification. It hasn't sense. So in this case, we have created this. But when it finished, it compares here this thing. What is? Is a sample file that has inside 3 files. The first is a model. Is the model that we have trained. The second is the scaffolding for make a fitting. So for make a training of the model. You see? And the second is a scaffolding in where we can find the concept, the principal concept of ML.NET. And now I explain you. You'll see that the model, that the dataset is 2 columns. The first column is the text, the second column is the sentiment. So these are the entry point of our model. In fact, for create our first experiment, we have to define the class of the model input, in where we have the text and we have the sentiment. For make a prediction, we have obviously to set up the score, because we need to understand if our model is if the sentence that we try to predict, we have to know the percentage where is positive or negative, right? And we have the prediction. In fact, we have a column name predicted label. Another important step is this. And this is the step in where that I show you in the third slide, where we have the workflow. We have a transform and we have some append. This is an important extension method of ML.NET that permit the developer to append a step by step. When the framework starts, I think 04 version, I think. And the concept of the pipeline, it was already inside the framework, and is an aspect important that we can that he permit us to add a sample step by step. And in case in where we have to modify our data set, it is very important to use it in this method. Okay. Is a sample, as you can see, is the sample API featurize, concatenate, map is very, very clear to understand, and is very simple. Predict. But one concept very important is ML context. ML context is a sealed class that can help us to use all the catalog of algorithm divided by type of algorithm. So we have a binary classification, a multi-class classification, regression, clustering, ranking, anomaly, and so on. Okay, so this is a sample thing for model builder. In this case, we have 50%. And the next step, we can evaluate. So we have a simple text box where we can try to our sentence. Obviously, the model is not training very well. So a simple wow, love this place we have on 50%. If we had trained the model for 1 minute, 10 minutes, is obviously we have another result in this case. The next step is very useful it's very useful because it helps us to use our code snippet for insert inside our application, and permit us to add our template, our model, in a solution template. For example, we can use it inside an API. If we have add to solution sample, we simple add the name, and it creates for us a project, a web API project with inside the possibility to call an API that is this predict. And we have this handler that with all we need to use our model inside an API. Okay, this is very cool feature, and because if you are a beginner and you need to start to understand how it works, the first aspect that I suggest you is to download to clone the repository of the framework and start to understand how the framework works from unit test of the framework. For me, is very important to understand all the concept, and because and you can see how apply some algorithm and how important and is well commentated, and it help you very much. And another aspect, well, ML context we already took. Now we try another thing. Let me see if okay. So we go on custom vision site. I log inside. Okay. Yes. I agree. I agree. Okay. So I create. I make a download about some photos. As you see, I make photos of dogs and cat. We have cat and we have dog. It's very simple. I use a simple 20 image for type. It's very, very simple. What we can do? I create this workspace in where for object detection, I make you a sample from the start. New project, object detection, and you can use a general compact and with the export capabilities. Okay. We have obviously you have a resource group where you place this particular space. And when Custom Vision create the space, you can upload images in very, very simple, with a very, very simple task. And you can open the imagine and start to tag. You see, dog, 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 dog. Okay. Now, what happened? Well, it happened one of the best things of this service. We have a performance. We have to define the iteration. The probability threshold is the score of the prediction. Try to imagine we have an image, and we have trained a model for the relevation of a particular object in the image, but is possible that you can relevate 3 or 4 images, 3 or 4 place of images. Why that? Because there is a threshold sensibility, and if you set to 50%, usually is very useful. If you go down, is not simple. So we have a test image, and we have the threshold. If we go on, you see, this is a particular photo. If I go down with the threshold, it relieves that this is a dog, but this isn't a dog, is a cat. It really for the system predicted dogs for 5%. So the threshold is a thing that we need to pay a lot of attention about that. If we start to go up with the threshold, you can see the difference. Okay, you can see the difference, and this photo is very useful for this. Okay. So we have a performance, and usually we start to training image, and the system make a training of this image with our tagging, and we have a threshold and overlap threshold. But we can make some prediction. We can make a quick test. Now I make a quick test. a quick test with this. Let me see. You see, the threshold is this. We have to go down for understand. Okay. 14%. This is a step very important that we have to remember, because when we go to try to use inside ML.NET, we have to remember the threshold about this image. Okay, so we close. Important step, export. Let me see. Okay, we have the possibility to choose our platform. We can use a Core ML, TensorFlow, ONNX, Dockerfile, Vision IE Dev Kit, and OpenVINO. No, our model is this, but there is a possibility also to use a TensorFlow model if we want. We use ONNX on this type, and we make a download. Okay. When we download the model, we try to go inside to understand. Wait, that is finished, but I have also a model. Wait 1 second. This is my house. Very beautiful Wi-Fi. Okay, thank you so much for the patience. So we go there and we make extract. Let me see. Okay. These are the file that the custom vision give to us when we download the model. We have a model on ONNX. We have a metadata properties, a label txt, in where inside there are a sample label, cat and dog. And we have a scaffolding for C# and Python. Well, C# is not for ML.NET, is another thing, and is not useful for us today, but is for Windows IE machine learning. Okay, there is a very long class of code, but it doesn't for us. Okay, but another aspect important is this, is our ONNX model. They go inside. Yes, we can use this tool that is Neutron, that permit us to go inside our ONNX model and try to see what are the property that we need for use this model. Allora, remember model output, remember data, and remember the size of the image that are 416 and 416. Okay. As you can see, we have an input and output in this case. Pay attention. If we use another kind of domain, the model probably change. And I want to see you this model that is always a sample object detection model. It's not this, is this. It is the same type of model, but have a very different model. as you see, is very, very different. And if you go inside the image tensor, we can see that the output is very different, but we have a detect box ticks, detect classes and scores. So we need to understand how we can parse it when we make a prediction of the model. We have to pay attention about that. Okay, so we start with a new project, a console application. And we try to do okay. So we have this, okay. And we start. So manage the NuGet packages. And we have to go Microsoft ML. With that download everything. Okay. We need this ONNX runtime. We need image analytics. And we need ONNX transformer. This. Okay. Okay. So the first, another thing, we go to add a folder. We go to inside model. Sorry. Open in terminal, and we go to pick up our model and our label. Very good. And we start to define our context. That is new ML context. Let's remember Visual Studio that we need this. Okay. We go to define a new class. New classes. We have to define model input, and we are going to define model prediction. Okay. Well, allora, in input, we define this. Model input, public bitmap. Image. Okay, we use these settings because we need. And if you remember, 416, it was the dimension about our image, and we use this data notation that is very important for us because we use inside the model where in input has this definition. Inside the output, so I intended the prediction, we go to define the column name, and sorry, we go to define the column name and the name of the output. Remember, we have model output 0, and it was this. Perfect. We have this. Now I use some classes because the time is not, it not help us. Bounding box. Very, very good. System drawing, please help us. And we use also this, where we go to define the bounding box dimension, where we are going to obviously to tag image, and we set all the things that we need for make a prediction. I have also to use some helper methods that I use here. Very, very good. Okay. Wait 1 second. Okay. Sorry, I make a little bit of mistake. Okay. And after, we are going to insert these parameters that are very important inside what are doing. Okay. And this. Okay. So we have created our context. We go to define a bitmap test image that is the image where we pass it to the model. And for the prediction, after we have created the ML context, we go to define the empty data. That is a new list of model input. Yes, model input is the model that we defined before. Is this, and we use it in there, in where we can define the data, and we use the context to define the load of the data. Okay. After we do that, we can create our pipeline. Our pipeline is very important because we go to define the transformation about the resizing of the image. So we pick up one of our image and we make our size that the model need. Okay. So we make a resize image, make a resizing, and we define the type of the resizing. So image resize estimator, we use the fill image resize estimator. Okay. After the fill, we go to define the output column name. Column name, and we define data. Try to. The column name was data. You see? Okay. And we go to define the image width. Image width. In where we set the image settings. Image, sorry, the weight. Okay, the width. And after we can set image height. Image settings. Image height. After this, we go on to define the input column. And we write name of model input image. Okay. Input, sorry, column name. Okay. After this, we use append. We use the append helper that help us to add context, transform, extract the pixels, put the column name, data. And we make another append where we're going to define the transformation of the model. Where is the model? And we go to define the model output and the input column name. The next step that we can do that is very important is the fitting, because we have make our pipeline and ours we are going to make a fitting. Now I try to make this so is more simple. Model input, model prediction. Model input. And we go all this set. If you remember, now I try to run. And after I tell you other things. If you remember that the time unfortunately is the build succeed. Okay, we try to run and we make a debug point for understanding better. Okay. If you see, we have a prediction about that, and this is the prediction. And we have this step that is the parse of the output. In the parse of the output, we have the probability threshold that is not very good for this, because if you remember, we use one image and we have some problem. So I restart. Okay. We are here. And we go here. If you see, we have a confidence. And we go on. I hope that if we go, okay. We have to understand if the threshold is correct for the images or not. Try to understand if we arrive in this thing. Okay, we have 0 because the threshold is very difficult in this particular image. Okay, and this is a sample of how to use the ONNX model in SciML.NET. In this sample, we have seen that we can use a custom vision to create our ONNX model, and we can training this model use custom vision, and we can use it inside our application with ML.NET for fitting and for make a prediction. We'll see that the prediction goes, but the image that I use are images that are not help us to make a prediction, because are very difficult to work on the threshold for understand where are the boxes. Now, if I have one time, I wanted to use 1 second for understand. Where is the custom vision? Okay, we have to make a prediction of this. Give me one moment that I see. This is the model. Okay. Wait 1 second, because I forget this. That is very important. Please remember always for me the problem is not there the problem, because I have pointed to a place in where I know that is present this, so is not a prerogative of this. And we have this CloudGen WeAreDevelopers. I try to see if we have and we use this. Maybe I think that is more clear. Last round. The problem of the threshold is a problem that is if you see, okay, predicted. And now is this is a dog. You see 37%. Okay. In fact, I will pass this. So I am at the end of this session. I hope that you like it. I hope that you like this you like this framework. And if there are any questions, I'm here.
Hi, Marco. Thank you very much for this nice overview. I think it was super interesting. And since we're a bit over time, I would jump right into the Q&A and take a few questions. Okay?
Okay.
Cool. So let me see what we have here. So yes, if you missed the session, you can watch it later on demand. So no worries about that. Then Lisa has an interesting question. How much data you would need to have precise predictions? Obviously, it depends, but is there a rule of thumb?
It depends because in my experience, object detection is a task that is very difficult to understand the data set. For example, if you have to recognize some section in a page, you have to training the model very hard with a tag that is very, very pixel based. If you have only to select a field where you have to define an image like the dog, you can use also a small data set. It's obvious that more big is data set, better you can train your model.
Okay. Thank you. Then let's see. Shapo has a question. He says he's a .NET Core developer. Do you have a suggestion for courses for ML.NET? How to jump in deep into the topic?
Oh, well, suggestion. Well, I think that start to know the framework is the first step is the unit test for understanding how to use the algorithm, because it's difficult to understand inside the framework all the things that you can do with an algorithm. So the process of the pipeline and the transformation. For me, you can try to use and see the sample that are very, very clear. There is also one my sample that is heart disease detection, and you can use it and you can try in very, very simple method. One sample that I suggest to you is the GitHub labeler. That is very, very useful for interact with the issues inside the GitHub.
Okay. Then Christian is saying thank you, interesting. Cerberus is saying cool. So you can also transform to TensorFlow. I think you showed that it's possible, right?
Yes.
And yeah.
Yes, you can, and it's very, very useful. And another step is that the possibility to include inside the framework the PyCharm that is a PyTorch wrapper in .NET.
Okay, then next question, does ML.NET run on Linux?
Yes, yes. Yes, absolutely. and run very good. And I think I usually use under Linux. And so I'm you can use it also on Mac, on Apple notebook.
Okay, that's cool. And Stravko has a question. So thank you, Stravko, for the question. How do you know what algorithm to choose?
This is the ML.NET use the algorithm that are defined in machine learning. So there are a lot of ways, but the principal concept is the question that you do before to start the analysis. For choose the best algorithm, there are a lot of questions that you have to do and a lot of tests. AutoML can help you to give you a direction, but for every type of algorithm, by classification, regression, object detection, you have to understand how this particular algorithm fit better on your dataset. The response is it depends.
Okay. Yeah, I think this is a response we often have, especially like depending on the use cases that you have and the product and what you want to solve. But it's a good answer, I think. Marco, is there anything else you want to share with the audience today? I mean, there was one question about how to get started, and you said like with unit tests. How did you actually start?
Well, for me, one thing that this framework has for the people that approach to ML is the documentation. I think that the team has made a very good job to document the software very well. So for a person that is a developer, can start there inside the code with no fear about algorithm or other. You can try with simple with the sample. For a person that start with ML world, it's start to understand the difference between a data scientist and developer, because is the first important difference that people need to understand for me.
Okay.
Data scientist is a person that make analysis to decide what is the best algorithm for fit the data set. Developer usually is another approach that is at the decision of the algorithm. I try to insert inside the code and use it for give the response. Are two separated words for me.
Okay, thanks for pointing that out. And with that, I would say, Marco, that was the last question. I'm super happy that you have joined us today and gave us these insights. But super interesting and very fresh presentation. So thank you again, and I hope to see you soon again at another event.
For me, I'm very happy to stay there today, and thank you for giving me this occasion to stay there. And thank you very much. Thank you to all.
Thank you. You're welcome. So see you next time again. And yeah, with that said, that was our last session. Very interesting machine learning in .NET. Actually pretty easy. And I think that was also some good starting point. If you have missed the session, no worries. You can watch it on demand later on. We have everything recorded. So yeah, you are ready to see everything in a couple of minutes after we close the stream again. Yeah, with that said, thanks to everyone for joining us today. Check out our upcoming events. Next week, we will have our mobile day. Then we will have a DevOps day. And don't forget our JavaScript Congress coming in November. We have very cool speakers like the inventor of Angular, the co-founder of NPM, and many other core contributors to popular JS frameworks and libraries. So check it out, get your ticket, and I hope to see you soon again. With that said, have a nice evening, or if you're in another time zone, have a nice morning, and bye-bye from my side.
Hello everyone, I'm Albert and welcome to adding AI or ML to your automations with AI Center. What ML models does AI Center offer? Great question. AI Center offers more than 25 pre-built ML models in document processing, object detection, text classification, sentiment analysis, entity recognition, demand forecasting, anomaly detection, and many more. If you want to use your own ML models, AI Center operates exactly how it would with a pre-built model.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.